right, so this is going on page 31 when we are finished. We're going to look at tests for symmetry with our graphs and then also even and odd functions. No, honey, the test is on Tuesday. That's why we have a calendar. It's what you should have written down.
I know it says like test.
Good Lord. Oh, that kind of test. Yeah. No, you're testing for it. We're not taking a test on it. No. All right, so tests for symmetry and even and odd functions. There are some things on these notes that I really don't like, and I don't know how I missed it before I made these copies because I should have gone in here and changed this stuff. But the terminology, you know, we talked a lot about correct notation and terminology and that sort of stuff, and then this is just a hot mess at the top. So this says the graph can be folded along a line so that two halves match. That's like a kindergarten explanation of this. That is not the academic language we should be using here. So really what's happening here is not that I'm folding it here. This is a what? What? Yes. But what's happening in the x-axis? It's not that I can fold it, but it is a reflection. Yeah, this is a reflection in the x-axis, right? And it's not that the top half gets reflected to make the bottom half. It's that if I take this and I reflect it in the x-axis and it coincides with itself, then it has that kind of symmetry. So this, we need to change a whole lot of this stuff up here. So it says the graph, we're going to, well, we don't have to take out the can be. We'll take out the folded along. Okay, it can be reflected across a line, not such that so that the two halves match, but across a line so that, now mark that out, it coincides with itself. If I reflect this in the x-axis, it's going to look exactly like it does right now. If I take this and I reflect it in the y-axis, then it's going to look exactly like it does right now. Does that make sense to you? Okay, so there's a reason this is connecting to the, you know, pre-high school geometry and then also high school geometry. You need to make sure you understand it's the same reflections. Those reflections and rotation rules that you talk about with the coordinates, that's what's happening here too. That's why we do it again, even though you've seen it so many times. So this right here, this one is a reflection in the x-axis. Okay. So that sounds weird maybe to you, but that's actually the correct terminology. You can reflect it across a line, over a line, or in a line. It sounds weird that it could be in a line, but that actually is the correct terminology. This right here is the reflection in the y-axis. So this can be called reflection or line symmetry. That, you start talking about line symmetry in elementary school, and you probably do start talking about it as a folding, but really that's not what it is. That's a line of symmetry because I can reflect it in that line. Then we have this one, and this one is, there's some bad wording here too. It says the graph remains unchanged when rotated 180 degrees about a point. That sentence doesn't even make any sense. You can't remain unchanged if you change it, right? So the graph looks unchanged when rotated 180 degrees about a point, and that point has to be the origin. Right? So that point right there, and when you do that, it looks unchanged because, again, it coincides with itself. Right? This is called point symmetry, or more specifically, origin symmetry, because it's the origin is the point of symmetry. So in a pre-P geometry class, you actually talk about this stuff when you talk about symmetry and reflections and rotations. And if you recall, we had the rotational symmetry, had those little toys out, those shape sorting toys for toddlers, right? And if you can rotate it and place it back in the toy, then it has that rotational symmetry. Because up until high school, line symmetry is the only kind of symmetry you know, so you just talk about symmetry. But there's also rotational symmetry, which comes into play here with our graphs. Okay, so if you rotate it 180 degrees, we have some sign rules, and if we reflect it in the x or y axis, we have sign rules as well. Okay, everybody good so far? All right, so then we can say that the, yes, x-axis and y-axis are common lines of symmetry, and the origin is a common point of symmetry. Those are actually the only ones we care about when we're looking at our graphs, because the graph can have a line of symmetry that could be the line x equals 3 or whatever. That's all fine and great, but that's not going to be as important to us as it having x-axis or y-axis or origin symmetry. Okay? So there's tests that you can do, not like a test you have to do on your own right now, but tests that you can do to see if it has x-axis, y-axis, or origin symmetry. There's graphical tests and algebraic tests. So for your graphical test, this is where those rules that you got from geometry come into play. So if we look up here, let me get that back up there. It says for every point x, y on the graph, the point blank is also on the graph. Well, when you reflect something in the x-axis, there's only one thing that changes. Is it the x or the y? The y. And what changes about it? It's negative. It's just the sign. So this just becomes x negative y. So if I look at this point would reflect down to here. Clearly the x values are the same. It's just the sign on the y value that changes. So the algebraic test is replacing y with negative y. When you do that, if you get equivalent equations, it has x-axis symmetry. Okay. So then for a y-axis, every point xy on the graph, the point negative xy is also on the graph, because that's what happens when you reflect in the y-axis. So your algebraic test is to replace x with negative x. Then origin symmetry means we have rotated it 180 degrees. So when you rotate it 180 degrees, what's your algebraic rule? Like, what happens to the coordinates? We flip them? They both flip what? Do we change the sign on both, or we literally flip them? They both become negative, because if I reflect something in intersecting lines, in this case, quadrant, if I reflect it in the y-axis and then I reflect it in the x-axis, it's the same as a rotation of 180 degrees. So at any time you reflect in intersecting lines, it's the same as a rotation, but it just depends on what the angle is. But since this is 90, when you reflect to reflect again, it's the same as a rotation. So if I reflect it in the x-axis, I change the sign on y. When I reflect it in the y-axis, I change the sign on x. So you're just changing the sign on both of them. When they actually change places, that's when you reflect it across the line y equals x. That's an inverse. But we just changed the signs. So the algebraic test then is to replace x with negative x and y with negative y, and see if you get equivalent equations. All right, everybody okay with that? And if we had to do only the algebraic test and not have a picture to go by to help us get started, then we would have to do all three of these to test it out. But these that we're doing right now, you're going to have a picture to kind of guide you in the right direction, and then you won't have to do all three every time. So this says, use the graph to determine if the relation is symmetrical to the x-axis, y-axis, and or origin. Confirm your answer algebraically. So if you look at number 1, does it have any kind of symmetry? Visually, yes. What kind of symmetry do we think it has? The line symmetry, which would be the y-axis, right? It does not have x-axis symmetry. If I rotate it 180 degrees, it doesn't look the same. So we're going with y-axis. So then we have to confirm this algebraically. If it has y-axis symmetry, our algebraic test, what do I replace? Do I replace x or y? X, because in the y-axis it's the x that changes. So y is equal to negative x to the 4th minus 4 times negative x squared. Did I substitute all that in correctly?
No, you got it.
Yeah, I got to put the parentheses. The parentheses matter here because it means two different things. I'm replacing the x with a negative x, so I need my parentheses there. So negative x to the 4th power is what? What happens? What is negative x to the fourth power is equal to what? X to the fourth power. So that's like negative. And anytime you have an even power, it just becomes positive. So x to the fourth power minus 4, what's negative x squared? X squared, right? And so does this look exactly like this up here? Yes. So I'm good. Okay, we okay with that? Let's look at number 2. Does it have any kind of line symmetry? Line symmetry? No line symmetry. Does it have, what does it have? Origin symmetry, okay? It has point symmetry about the origin, so there's origin symmetry. So the algebraic test for that is to replace what? X and good. So the x is going to become negative x, y becomes negative y, and that's equal to 6. So what's negative x times negative y? xy. And that is 6. And that matches that, so I'm good. So I know what some of you are already thinking, and Tuan will probably eventually ask me, do I have to substitute those in? Because I can just look at it, I know it's going to give me the same thing. So what do you think the answer is to that? Yes. And why? Because I said so? No, because it says confirm your answer algebraically, right? You're not testing it for yourself to be confident that you have the right answer. You're doing that because it says you have to. Your work is you doing it. This is your answer, your proof. Yes, sir.
Isn't it also reflection across the line y equals x squared?
Y equals negative x.
Yeah.
And it very well may be in this case. I think it is. Yeah. But we don't care about that right now. So yes, it is. So it does have that line. So I shouldn't have said, does it have any line symmetry? It has line symmetry, but it doesn't have the line symmetry we're interested in. Because right now, we only care about x and y axis. But yes, you're right. Okay. Anything else? Okay, good. All right, let's look at the next one. All right. So on this one, first of all, that is a graph of what? What is that thing called? What's the math word for it? Thank you. It's an ellipse. Okay. So this is an ellipse. And just the ellipse itself, does it have line symmetry? Just in any ellipse that you could just like hold in your hand? Yes. Does an ellipse have rotational symmetry?
No. Well,
yes, just like if if you could hold it, yes, it does, right? Now, this one, it still does have point symmetry, but does it have the point symmetry we're interested in? No, so we don't include it because it's not about the origin. Does it have x-axis or y-axis symmetry? X-axis, okay? So x-axis symmetry, which means then we in a negative y. So this is going to give me 4 times x plus 3 squared plus negative y squared equals 16. So I know I can like multiply all this out. Do I need to do that? No, I'm trying to make it match. So don't be doing stuff just because you can do it. This is how I want it to look. So 4 times x plus 3 squared plus what's negative y squared? Y squared. And that equals 16. So those match, right? And we would expect that. So that's good. So let's just, little side note here. Again, I could multiply all that out and I could distribute my 4 and I could do things, I could do some other things, and then I could, after I multiplied it all out, I could factor it back the way it was. But just because you can do stuff doesn't mean you need to do it. On that quiz, some of you went too far. Like you multiplied everything out like it told you to, and then you factored something back out, which as long as it was still correct, I gave you credit for. You just didn't need to do that. So you need to learn how you're supposed to know when to stop, because some of you took it too far and then messed it up. Or you're just doing all kinds of stuff. It's like you just do stuff because you can, which tells me you don't really have a clue why you're doing what you're doing. So just make sure that you're not doing too much, because you usually make it harder on yourself. All right, so number 4. Does it have any kind of symmetry we're interested in? Does it have x-axis? If I reflect it in the x-axis, is it going to look the same? Yes. If I reflect it in the y-axis, is it going to look the same? Yes. If I rotate it 180 degrees about the origin, is it going to look the same? Yes. So it has all 3. okay? So, and then I'm going to number them 1, 2, and 3 because we have to confirm all 3 of them, all right? I know. Oh. If you think this is bad, honey, this ain't nothing. All right, so x-axis, so I numbered them so I could kind of show which was which so I didn't have to relabel them with words. It's just like an easier way to do it. So for x-axis, I substituted a negative y. So this is going to be negative y squared minus x squared equals 1. So negative y squared is y squared. So y squared minus x squared equals 1, and we're good. All right. So then I have to confirm the y-axis, which means I substitute in a negative x equals 1. All right. So then that's going to give me y squared minus x squared equals 1. And then origin, I replace them both. So negative y squared minus negative x squared equals 1. Got room there. And that gives me y squared minus x squared equals 1. Okay? Everybody okay with that? We good? All right. See, it's not that big of a deal. That's easy, right? So we don't complain about having to write stuff down when it's easy. We're thankful that it's easy, and we just do it and move on. All right, so I'm going to give you a minute. I want you to work on 5 and 6 on your own, and then we'll talk about them. All right, Ernest, tell me about number 5. Does it have any symmetry at all that we're interested in? No, right? Does it have rotational symmetry at all? Yes, but not about the origin, right? So then my answer is none. Okay, good job. Those none, well, the none's a choice though, so I know it throws you off. You're like, I'm not sure. All right. So then, let's see. Jonah, help me with number 6. X-axis, y-axis, origin, or none? Y-axis, okay. So then we substitute in, we get y equals negative absolute value of negative x minus 2. And then what's the absolute value there? Hey. So negative absolute value of x minus 2. Okay, we agree with that? Good deal. All right, any questions? All right, so that's symmetry, x-axis, y-axis, origin. So now we're going to extend that and talk about even and odd functions, which when I asked last period, they told me, yes, you do this in algebra 2. I think it's one of those things that sometimes don't, but even and odd functions. What I do know is took pre-P geometry, then we did talk about them. We just talked about them from a visual aspect, and we just looked at them when we did symmetry and rotations and stuff, because I wanted you to make that connection. I don't think the connections throughout your courses are always made for you. So we just looked at them and kind of try to connect it there. But we got even and odd functions, which just has to do with the symmetry. The key here is that these are functions, right? So a function is even if it is symmetric with respect to what? Who remembers and can tell me that? And I'm going to go down the hall and tell Ms. McWhorter you don't remember if you don't tell me. The y-axis. Good. You got a 50-50 shot here, right? It's either y or x, so I mean, might as well take a shot. So y-axis symmetry. So here are the key words too. First of all, it is a function is even if it is symmetric with respect to. So remember, correct terminology, correct verbiage is important. Symmetric with respect to the y-axis. That means the y-axis is a line of symmetry. You can reflect it in the y-axis. So your algebraic check for this is that you see if f of negative x equals f of x. If it does, then it's an even function. Okay. Then we have, so let's look up here. Were any of these up here even functions, just visually? Symmetric with respect to the y-axis. Which one of these are even functions? 4 and 6. You think y'all agree with both of those? No. Only 6. Why? That's why. It has to be a function. A function is even. So this is not an even function because it's not a function, right? If you got all three, you're not a function, all right? So it's not just about y-axis symmetry. That's why we're talking about it separately. It's about being a function with y-axis symmetry, okay? So there you go. All right, so then a function is odd if it is symmetric with respect to the what? X-axis, you think?
No.
Origin. Okay, because what happens when you're symmetric with respect to the x-axis? You're not a function, right? If you can reflect in the x-axis, you're going to fail that vertical line test every single time. So, the origin. All right, so a function with symmetric with respect to the origin. So, the x-axis symmetry has nothing to do with even and odd because that means it's not a function, and these are functions that we're talking about, okay? We talk about relations in general, so we can talk about graphs, but really most of our time is spent talking about actual functions. So your algebraic check here is you're still checking for f of negative x. So the good news is here is that you start them the same way. Whereas the other ones, if you're just looking for x-axis, y-axis, or origin, you start all three of them differently, so you'd have to do like 3 different ones. Here, we're still looking for f of negative x. If it gives us f of x, it's even. If it gives us negative f of x, it's odd. If we don't get either one of those, then it's neither. It's just some function, and it's not even or odd. Okay, we good? Any questions? All righty, so let's look at some of these examples here then. Says determine algebraically, so we don't have pictures to go by, so we got to do this the algebraic way, f of negative x. Make sure you write that down first so that you say what you're doing here. And then I've got negative x to the third power, got to be in parentheses, minus a negative x. So what's negative x to the third power? Negative x to the third power. What's negative x? Positive x. So, does this equal f of x? No, it doesn't look identical, so it does not equal f of x. Does it equal negative f of x? Yes, if I multiplied this by a negative 1, that's what I would get. So this equals negative f of x. So is this even, odd, or neither? Odd. Okay, so this is an odd function, so we have to put odd. And then we have to also say that it is symmetric with respect to what? Origin. Thank you. Okay. Symmetric with respect to the origin. All right, so let's do number 8 together. We're going to do f of negative x equals negative x squared plus 6. So just that in the parentheses, that negative x squared becomes positive. So that means I have a negative x squared plus 6. And it is equal to f of x. So is it even, odd, or neither? Even. It is even because symmetric with respect to what? The y-axis. Okay? So you have to say y, you have to say even or odd, and then y, and then your work is also part of that y. That's showing you how you know it's symmetric with respect to the origin or the y-axis or whatever. Okay? We all good so far? All right, let's do 9 together. So f of negative x is equal to negative x cubed minus negative x squared minus 2 times negative x. Okay? So negative x cubed is negative x cubed, right? This becomes negative, and then that's a positive x squared. And then negative 2 times negative x is positive 2x. Okay. So I can tell you just by looking at the first term, it does not equal f of x. Does it equal negative f of x? No, because if it did, then all the signs would change, right? So this is neither. And then your work to show that is your justification of why it's neither, because you got that and it doesn't equal either one of them. Okay. Everybody okay with that? All right, so I want you to do 10, 11, and 12 on your own, and then we will talk about them. I'll give you a few minutes. Alrighty, let's see. George, why don't you help me with number 10? I'm going to do f negative x equals, I should have already done this part. Just tell me, did I substitute that in correctly? Yes, okay. So then, George, my next step, then what's this going to give me? Okay, is that going to give me x minus 2? No. All right, everybody listen, and everybody look right here. This does not become x minus 2. You cannot separate that into 2 square roots right there. Don't do that, okay? All right, not that he was doing it. I'm just saying. There's this quiz on that one. Oh, good God. All right, so keep going. So now, what does this equal then, George? F of x, okay? So then that tells me what, George? It's what kind of function? Even. And that means that it is symmetric. Good. Symmetric with respect to the y-axis. Thank you very much. All right. Everybody good? Any questions? All righty. So then, let's see. Raphael, let me substitute in first. F of negative x is equal to negative 8. So did I substitute that incorrectly? I didn't. I'm talking to Raphael. Raphael, what did I not do right? Okay, so I can put my parentheses there. Now, parentheses is good, and it's good that you put them. The fact that I left them off, would it change the problem? It actually wouldn't here. If I left them off here, it changes it, right? Here, it actually doesn't, so it's okay, but I'm glad that you corrected me on that. Okay, so then what would my next step, Raphael, look like? What would this reduce to? Right. So if you have negative over a negative, what do you get? Positive. So this is going to give me 8 over x. All right, so clearly it does not equal f of x, but Raphael, does it equal negative f of x? No. Y'all agree with that? Okay, so look at this. If f of x is equal to negative 8 over x, then negative f of x is equal to negative 8 over x. Do I take this negative and put it on the top and the bottom? Y'all are going to make me cry. No. This is like a negative 1. Okay, here's some 4th grade math for you. So negative 1 times negative 8 over x. When you multiply by a fraction, you can put it over 1, and you multiply straight across, right? And it gives you 8 over x. Guys, that can't stump you. It stumped every single one of you there. So 8 over x then, does it equal negative f of x? What do you think, Raphael? It does. This is negative, can't even write. It'll catch up. Hang on. There you go. Negative f of x. Make sure you understand how to handle that with fractions. That actually got some of you to get some things wrong on your homework. Depending on where you put that negative, y'all are just like free with that. You just stick that out there anywhere. So since it equals negative f of x, Raphael, is it even, odd, or neither? Odd. So it is odd, and it is symmetric with respect to what, Raphael? If it's odd, look back up here. To the origin. All right. So then f of negative x here is equal to the absolute value of negative x plus 1. Whether I put this in parentheses or not, is it going to matter? In this case, no. So I can, and then I can simplify to this. Can I simplify this anymore? No. So it's obviously not f of x, right? Is it negative f of x? Not that either. So this one is neither. All right. Okay, any questions? Now, this is an example of not just the fact that you have to show your work, but your work is your answer. Like if you don't have that, you're not even answering the question because that's part of it. Okay, are we good? All right, awesome.